Section 10.9 is systems of inequalities. And what we'll see is first, just a basic example of graphing the inequality y is less than or equal to negative 2x plus 3. Now, the biggest thing to understand with the idea of inequalities that you're graphing is the idea of shading. So what happens is instead of having, say, 1, 2, or some finite number of solutions, you have an infinite number of, in this case, x and y values that would make this inequality true. By shading, you're including all of those possibilities and showing what they are and where they're headed, just because we have a finite graph here as well. So the steps, as you can see, for a situation like this would be first graphing a boundary line. So what we notice, or what we remember, is that this, putting an equal sign, is a line. And more importantly, it's a boundary line, meaning that on one side of this line, it will not make this inequality true, and on the other side of this line, it will make the inequality true. So once we draw this line, we have an idea of, we know where the boundary is, and then we just go from there. So a couple things to think about is so just a side note before I draw the line, because we have, it is not the prettiest because there, because we have less than or equal to. So notice the inequality is less than or equal to, specifically that equal to. The line that we create, the boundary line, is going to be solid. Line is solid. Solid line we're going to graph. So we want to just graph y equals negative 2x plus 3. You should know that this is already in slope-intercept form. So negative 2 over 1. We have the y-intercept. Y-intercept is 0, 3. So just knowing this allows us to graph the line first. So 0, 3. Then we have the negative 2 over 1. So I'm going to go down 2 over 1, up 2 over 1, up 2 over 1, and like this. Then what I was saying before is, because we have an equal to sign, because equal is part of our inequality, the line is solid. And that's because any point that's on this line is going to make this inequality true. Getting a little away from it here. So because of that, we make the line solid to say, hey, this line is included. Any point on this line is part of our solution. So that's why we make it solid. Okay, that's what I'm gonna do. Okay, so we have our boundary line. So like I said, one side of this will be our solution and one side won't. And the way to find that is fairly straightforward. We do what's called a test point. Test point. So we pick a point, any point at all, on either side of that line. We put it in for x and y, and we say, does it make our inequality true or not? If it makes it true, it's part of our solution, and any point on that side of the inequality will also make it true. So a great point in this case is 0, 0. 0, 0 is a great test point. And so all we do is plug it in and check. So I have y is less than or equal to negative 2x plus 3. So I plug in 0, 0. I have 0 is less than or equal to 3. I check, is that true? Yes, it is. So that tells me to shade side with the 0, 0. So now I'm going to come back, and it's exactly what you think. I'm just going to shade this side. I'm shading the whole side. Now, what you want to understand is that any point that is on that side. So I picked 0, 0. I could have picked negative 4, 1. I could have picked 0, negative 4. I could have picked negative 3, negative 3. Anything on that side I could have picked, and it still would have been true. The inequality would have been true choosing that point. If I had chosen anything on the other side, I would have had something that was not true. It would have given me something false. That would have told me, don't shade that side, because none of those points are going to make the inequality true, and therefore none of them should be part of our solution. So that's the big idea that's happening here. And then we have 2. So now we have 2 lines. So notice both of these are linear. We've got 2 lines that we need to graph, and then we'll take a look and see about these inequalities. So what I want you to notice first, we're going to be graphing the line y equals 2x minus 4, 2x minus 4, and y equals negative 2x. So 2x minus 4 and y equals negative 2x. So that's the first thing we're going to do. Notice, both of these inequalities do not have an equal sign. Both of them are less than. So because there is no equal to as a part of it, both of these lines are going to be dotted lines. The dotted lines mean this line is not included, but any point, on one side of this line, depending on, what the inequalities are, we'll have an area that we're shading, either is or isn't shaded. So it's the boundary line. But by being dotted, it's kind of like this invisible line that we cannot touch because no point on that line is part of our solution. So if you want, you can pause, graph the 2 lines, and then we'll go from there. So the first one, negative 4, and then 2. Got a lot of slopes of 2 on this. That was not intentional. Okay, so I'm going to make my line dotted. The dotted might be a little bit easier for me to draw. I don't have to worry so much. Okay, with my arrow, head up the other way, arrow. Okay, dotted line. Excellent. Now, other line, that was the first one. Then I have y equals negative 2x. So that has an intercept of 0, 0. There's no y-intercept there, plus 0, basically. And then that negative 2 again, just starting at our point there. So I'll have here, and here, and here, and here, and here. Okay, so another dotted line, another dotted line. Now what I want you to look at is how many quadrants or regions are created by having what we have here, these 2 lines intersecting. Hopefully you notice that there are 4 regions. 4 regions. So a couple different ways to go about it. Test points. So again, we have 4 regions. You do not have to check 4 different things. You don't have to check 4 different things. A couple different ways to go about it. You could start with one of the 4 regions. So I'll erase this, but notice that the idea here is we have 1 region, 2 regions, 3 regions, and then 4 regions down here. Those are our 4 regions. And so by knowing that, that's what we're trying to find, is that which one of those needs to be shaded. It has to make both of our inequalities true. So typically what we do is we pick a test point. We do not pick a test point on the boundary line. So notice I won't use 0, 0 this time, just to kind of show you something different. And because one of those lines does include 0, 0 on the boundary line. So let's test negative 1, 0. So I'm going to test this point right here. Okay, I'm going to test that point. So I put it into my first inequality, 0 less than 2 times negative 1 minus 4. So that gives me 0 is less than a negative 6. Is that true? Okay, that is false. Okay, that is false. So when I think about my first line, which is over here, when I think about that line, notice if you just look at that line, you have above it and you have below it. So, or maybe, I'm trying to think, you guys are mirrored image. We have above it and we have below it. I picked a point above it and it makes it, as you can see, it makes it false. So that tells me it's going to be below. So by doing this, it's telling me that, and I'm gonna have to, I'll do this and then I'm gonna do, don't shade yet. So it's telling me false, so that I'm gonna be over here. Okay, so just bear with me on this. Maybe, this is nice. Boom, okay, maybe I'll actually do, let me do yellow. We'll see. I got a plan, everybody. I got a plan. So don't shade. There we go. So it's over on this side. So I'm just thinking of it in terms of above and below that line. Then I will try the same point. I can try the same point if I want in the other line, that other inequality that we have there. So I put 0 is less than -2 times -1. Is 0 less than 2? Okay. Now that is true. That is true. So when you think about that, it's telling me, so look at that -1, 0. It's telling me that I want to shade anything on the side of the second line. So our second line is here. We have above that line and we have below that line. So it's kind of like, if you're looking at it, kind of like to the right of that line or to the left of that line. We want to be to the left of that line because we want the side that has -1, 0. So that tells me I'm going to shade all of this. Okay, don't worry. I hope you're not shading yet because I'm not ready. Okay, then the answer to our system, because we have 2 of these, the answer to this system is the overlap, because it's the area that makes both of them true. So as you can probably see, that's happening down at the bottom. It's happening down at the bottom in this region right here. So let me make that, okay, let me think about this. Okay, so I want this region down here, just that region. So now let me see that. It's not too bad. Okay. So now let me, I'll do red. And now I'm just going to shade this middle part. And if you want, you can always check your answer. You can find a point that sits in this area right here, test it in both of your inequalities. It will make both of them true. And that is, a way to tell yourself, yes, that is the region that I want to be shading. So now we have a non-linear example. And so the first thing is still to do this boundary line, the boundary lines that are needed. The first thing we have is x squared plus y squared equaling 25. So I put that equal to sign and then I take a look. You want to be able to recognize x squared plus y squared equaling a number is a circle. You want to be able to recognize that that is a circle. That's a circle. It has center 0, 0. It has radius 5. So all you need to do to draw this boundary line is put your values at all the different nice, 0, 5, 5, 0, -5, 0, and 0, -5, and then connect them. Notice we have a less than sign in the system. So we should have something that is dotted. We should have a dotted system here. So this boundary line is what I should say. The boundary line should be dotted. So I'm going to go ahead and do the best I can to create a circle. You do the best you can to create a circle. No matter what I do, it's probably not going to feel great. But, ooh, that one's not too bad. Okay, all right, so here is our circle. So notice that we have inside the circle and we have outside the circle. So when we think about using that inequality sign, less than or greater than, you want to think outside the circle or inside the circle. But it's not the only thing we have. We also have the boundary line y equals 3/4 x. That is a line, but because of the greater than or equal to, the line should be solid. So if you want, you can go ahead and graph that line. It has intercept 0, 0. You can see what the slope is. See if you can graph it. All right, so we'll be up 3 over 4. And then I'm going to be down 3 over 4. Okay, now we're going 3, 0, 0. And then I want it to be solid. Getting the hang of it just when we finish. Okay, so so there we go. So there is our line. Y is equal to 3/4 x. And now we just have to decide where we are shading. So do notice there's some different regions here that we have to think about. As long as we pick something that is, in one of the regions, we check and see if it makes both inequalities true. So what am I going to do here? I realized I've made this graph enormous. Where am I going to put my face? Okay, so let me just do the test point up here, everyone, just to have a space for my face. All right, so test point here, I don't want to use 0, 0. You might notice the inequality sign. You have to be a little bit careful, but we have x squared plus y squared has to be less than 25. The idea of less than means you could probably pretty easily see, hey, if I put in the point 1, 1, I'm going to have 1 squared plus 1 squared. Is that less than 25? Yes. I'm going to think about -3, 1 as a possible point, or 3, 1. So I put in 3, 1, and I get 3 squared plus 1 squared. Is that less than 25? Yes. So it's not hard to see that in this case we are going inside the circle, less than 25. So we actually are going to be inside it. So, I'll do a test point here. I don't want you to think I'm not doing a test point. So let me do 3, 1, and that gives us 9 plus 1. Is that less than 25? It is. So I'll do this again where I kind of do the whole thing and then I erase some, so don't shade yet, but it is telling us that for the circle piece, that we are everything inside the circle. Now for that line, we just have to say, are we up here above that line, or are we down below that line? And we just check something else. So we could check the 0.31. So if we check the 0.31 in the second one, we have is 1 less than or equal to 3/4 times 3. So notice that's going to be is 1 greater than or equal to 9/4. It is not, so because 9/4 is more than 1. So that tells us not to shade below, not to shade where we see 3, 1. We want to shade the other side. So again, I'm going to erase here in just a second. So that's telling us we want to be all the way, where am I? All the way above this line. There we go. Oh, I'm doing there. Okay. Here we go. So we're all of this. Okay. Now, hopefully you see the overlap. Hopefully you see where the green and the yellow are overlapping, and that's all we want to include in our answer because that's the area that makes both of them true. So I'm going to erase all of that and now come back and just shade this area here. So that's an example of a non-linear system of inequalities. There we are. Boundary lines, test points, shading, and you're done. And that's section 10.9.